In today's video, I am going to continue solving KC 2025 Physical Science question paper. Yes, let us start with the first question. What we have, a one-dimensional box of length L is occupied by 11 non-interacting spin-up fermions. If the lowest one particle energy is zero point 0.5 electron volt, then the minimum energy of the system, that is complete total system, what is the minimum energy they are asking. So here they have given it as a one dimensional box. For a one dimensional box, the energy we have En, which is equal to n square pi square h cut square divided by 2 times of m into a square. This is a formula for a one dimensional box of length L. And here they have given one more thing, that is a spin half fermions. Means spin half is nothing but the spin which is having the spin to be half, means it belongs to fermions only. Okay, in fermions what happens means it will only follows the Pauli's exclusion principle. It will obeys the Pauli's exclusion principle. What does this principle says means only in each energy level can hold a maximum of two particle itself. I am repeating again, each energy level can hold a maximum of two particles, that is one spin up and one spin down. Okay, now according to this, a maximum of two particles in the sense for n which is equal to 1, it can have two fermions, right? For n which is equal to 2, it can have again two fermions. For n which is equal to 3, it can have again 2. For n which is equal to 4, it can have again 2. For n which is equal to 5, it can have again 2. For n which is equal to 6, it can have again 2. But what they have given? They have given here 11. If I add all this, I'll get the sum to be 10. So one more fermions I need to add. So it will make 11 non-interacting spin half fermions. Now the energy En can be found out by the formula. These everything is constant. What it is depending at, depending on the n square into E1, that is the initial energy. So n square into E1 will be the initial energy. Now instead of n, if I place n to be equal to 1, it will be 1 square into E1 is zero point 0.5 electron volt. So the value will be zero point 0.5 electron volt. Like that, if I keep 2, n value to be 2, 2 square into zero point 0.5 electron volt. So the value will be 2 electron volt. Like that, if I keep E3, so I'll get the value to be 4.5. If I place n value to be 4, I'll get the value to be 8 electron volt. If I place n value to be 5, I'll get the value to be 12.5 electron volt. If I place n value to be 6, I'll get the solution to be 18 electron volt. So this is what we got the n, that is for n which is equal to 1, 2, 3, 4, 5, 6. Now our task is to find the minimum energy of the system, that is the total energy. Total energy can be found out by 2, means only two fermions can be accommodated in the energy E1, right? So 2 into E1 plus 2 into E2 likewise plus 2 into E3 plus 2 into E4 plus 2 into E5 plus 1 into E6. Why? Because only one fermion can accommodate in the final n which is equal to 68. Why? Because only 11 non-interacting spin half fermions they have given. So if I solve the E1, E2, E3 values, let me take 2 to be common. What is E1? 0.5, E2 is 2, E3 is 4.5, E4 is 8, E5 is 12.5. Here we don't have 2, so we will divide it by 2. 18 divided by 2 will be 9. So on adding and multiplying, I'll get the answer to be equal to 73 electron volt. So the option, fourth option is the right option. I hope everyone is clear. We shall move to the next question. What we have, 51st question, the dimension of phase space of 10 rigid diatomic molecules. They have given to find the dimension of the phase space. The formula to find the dimensions of space phase space is given by the equation I'm going to write now. Phase space, that is equal to 2 times of n into f, where f we call it as a degrees of freedom. We have studied in the lower classes. This is the degree of freedom, and n, which is the number of molecules. They have mentioned number of molecules in this question is 10. So what is this degree of freedom? They only given it is a diatomic molecule. We have already studied the degrees of freedom for diatomic molecule, that is f, which is equal to 5. In place of f we will place 5. Instead of n I'll place 10. Why? Because they were already given it is a 10 molecules. So I'll get 2 into 10 into 5. So it will be 2 times are 20, 20 into 5 to 5 is a 10. So it will be 100. Right. So I hope everyone is clear. So the solution we get here to be 100. Let us move to the next question. What is the next question? Here we have the next question. The pressure P of a gas of a ultra relativistic electrons with internal energy U and the temperature T is given by. So we have a relation. It is a direct question for a gas of ultra relativistic electron with internal energy U and the temperature T. Directly I am ticking to the option C because it is a direct question. Pressure, it is related to the internal energy, and the volume be like this. Okay, now let us move on to the next question. What we have in this question, an ideal gas of fermions is at 0 Kelvin temperature if the mass of the particle and their number density are both reduced by a factor 2, then the corresponding Fermi energy is multiplied by the factor. Okay, so they are asking the factor. Now the formula for this Fermi ions is at 0 Kelvin temperature if the mass of the particle and the number density are both reduced by a factor of 2, means the corresponding Fermi energy. Now the Fermi energy is given by the formula, that is EF, which is equal to h cut square divided by 2m into 3 times of pi square n into 2 to the power of 2 by 3. So this is the formula they have given. Now what they are saying here, let me tell you the formula, describe you the formula. Here m represents the mass of the particle, of a single particle, and n represents the number density of a particle. Here they are saying the number density and the mass is reduced by 2, means initially it is m, finally it is m star. Let us consider it will be m by 2. If the number density initially it is n, so n star, the new number density will be n by 2. Now ef star, what we want that answer ef star, which is given by h cut square divided by 2 times of m star into 3 times of pi square. Instead of n it will be n star to the power of 2 by 3, right? I'm taking this to be equation 1 and this to be equation 2. What I'll do 1 divided by 2. If I do 1 divided by 2, I'll get ef divided by ef star, which is equal to h cut square divided by 2m all divided by h cut square divided by, instead of 2m star, what I'll get 2 times of m by 2, right? Now into 3 pi square into n to the power of 2 by 3 divided by 3 pi square. Instead of n star I'll get n by 2 to the power of 2 by 3. Here h cut square divided by 2m, h cut square divided by 2m get cancelled. We are here also 3 pi square and 2 by 3, 3 pi square 2 by 3. We are left with 1 divided by 1 divided by 1 by 2, right? This is what we are left with. Into here this side, into 1 divided by 1 by 2 to the power of 2 by 3, right? So if I simplify, I'll get here 1 divided by 2 into 2 to the power of 2 by 3, right? So I'll get, after simplification, 2 to the power of 2 by 3 minus of 1. Here we have in a denominator 2. If it goes to the numerator, 2 to the power of minus 1. So after taking LCM and solving, I'll get 2 minus 3 divided by 3. So I'll get 2 to the power of minus 1 divided by 3 to be equal to, I'm continuing here, it is equal to, that is EF divided by EF star, which is equal to 2 to the power of minus 1 by 3. Now what I want the value of EF star in terms of EF. So EF star, which is equal to EF divided by 2 to the power of minus 1 by 3, minus, if it goes upside, it will be plus. So 2 to the power of 1 by 3 into the initial energy, right? So we got the answer to be equal to 2 to the power of 1 by 2, option 2. Sorry, it will be 2 to the power of 1 by 3. It will be 2 to the power of 1 by 3. Option 1 is the right option. I have written here clearly, but while marking, I marked the wrong. So it is, the answer is 2 to the power of 1 by 3. Yes, let us move on to the next question. What we have? The number of ways in which n identical bosons can be distributed in two energy levels is. So we have a formula. It is very easy question. The number of ways in which n identical bosons can be distributed in two energy levels, that is given by the formula, that is Ni plus Gi minus 1 factorial divided by Ni factorial into Gi minus 1 factorial. Okay, this is the formula. Here n is the bosons, you can call it as a number, and Gi is the energy levels. Here they have given Gi value to be equal to 2 and Ni value to be equal to n. Okay, now substitute for Gi and n in this formula. I'll get, instead of N plus Gi is 2 minus 1 factorial divided by Ni factorial is n factorial into Gi minus 1 is 2 minus 1 factorial. So after solving, I'll get n plus 2 minus 1 is 1. So n plus 1 factorial divided by n factorial into 2 minus 1 is 1 factorial. 1 factorial is again 1. I can expand this. After expanding, I'll get n plus 1 into minus 1 factorial into n plus 1. It will be in the prior, n plus 1 into n plus 1 minus 1 factorial whole divided by n factorial. So I'll get, after solving, it will be n plus 1 into n plus 1 minus 1 get cancelled. So it will be n factorial divided by n factorial. N factorial and factorial get cancelled. The solution is n plus 1. So n plus 1, that is option 2 is the right option. Yes. Let us proceed to the next question. We have in the next question, if a peak radiation of the sun occurs at 800 nanometer and assuming the sun to be a black body at a 6000 Kelvin temperature, then what would be the wavelength at which there is a peak radiation if we assume it temperature to be a 300 Kelvin? It is very easy question. It is from a Wien's displacement law. Easy question. Wien's displacement law for black body radiation. So according to the Wien's displacement law, what does the law says? The wavelength is inversely proportional to the temperature. So from this law, I can write it as lambda T, which is equal to constant, that is B. That is a Wien's displacement constant, we call it as. So here they have given the lambda 1 to be equal to 800 nanometer, and it is at a temperature T1 which is equal to 6000 Kelvin, and lambda 2 only we want to find, and what they have given, and the temperature T2 which is equal to 300 Kelvin they have given. No, from this equation I can write it as lambda 1 into T1 which is equal to lambda 2 into T2. No, so from here I can write lambda 2 which is equal to lambda 1 into T1 divided by T2, right? Instead of lambda 1, I can substitute the value 800 nanometer into temperature is T1 6000 Kelvin divided by 300 Kelvin. Kelvin get cancels, two zeros get cancels, 3 ones are 320, 2 eights are uh, 16 16,000 nanometer. So they have given in terms of micrometers. So 16 into 10 to the power of 3 nano can be written as 10 to the power of minus 9 meter. So 3 minus 9 is minus 6. So it will be 16 into 10 to the power of minus 6 meter can be read out as 16 microns. Right, option 3 is the right option. Thank you for watching. For more videos you can visit my YouTube channel.